All right, so welcome back to E75. So this is lecture 6, JavaScript, where we start to look at things more client-side than server-side, but two topics first. One about MySQL in the cloud, and two about session hijacking. So recall that earlier in the semester, we talked about some of the threats, if briefly, that are posed whenever you're using the internet these days, specifically the web. And one of those was called session hijacking, whereby you can relatively easily intercept the so-called session cookie that a server is using with a browser to maintain state. Because recall that those cookies are generally not transmitted via, not SSH, but SSL from HTTPS. So that actually is a pretty easy solution to this problem, but most sites don't do it. And why don't most sites, including the most popular, tend to even use SSL perpetually on every page? Yeah, so the overhead, the performance. If you're as big as someone like Google or Facebook, or even frankly someone smaller but whose resources are limited, any additional CPU costs that you have to incur to handle the crypto involved in SSL just means one fewer users that you can handle per second, which means you need more hardware, more servers, more money. So there's actually a pretty compelling trade-off there between security and actual dollars. Well, a friend just forwarded me this article, and I'll pull up a screenshot in a moment. This is from a website blog called TechCrunch. The topic is Fire Sheep in Wolves Clothing. Extension lets you hack into Twitter, Facebook accounts easily. And the article, just a couple paragraphs here, is it seems every time Facebook amends its privacy policy, the web is up in arms. The truth is, Facebook's well-publicized privacy fight is nothing compared to the vulnerability of all insecured HTTP sites. That includes Facebook, Twitter, and many of the world's most popular destinations. Developer Eric Butler has exposed the soft underbelly of the web with his new Firefox extension called Fire Sheep, which will essentially eavesdrop on any open Wi-Fi network and capture users' cookies. As Butler explains in his post, as soon as anyone on the network visits an insecure website known to Fire Sheep, their name and photo will be displayed in the window. All you have to do is double-click on the name, and open sesame, you will be able to log into that user's site with their credentials. And the screenshot here, I imagine this is downloadable on the web. It looks a little blurry, but it looks like if you pull up this extension, pull up a slightly blurry photo here, and click Start Capturing, what you get is all of the local people who are logged into Twitter, Facebook, Flickr, Google itself. And it's just made it that easy. So what's interesting here, or what you should be mindful of here, is this guy didn't do anything that's all that magical, right? He essentially just made it easier to do what you could already do with Firebug or a lower level tool called Ethereal, or aka Wireshark, to just sniff this traffic and then manually spoof the requests. Unfortunately, it seems people have made this all the easier. So what's the solution? I mean, frankly, probably what Google did a few months ago by transitioning their users to SSL is ultimately the solution here. Just how soon some of these sites do it remains to be seen. Yeah?
So even if your wireless access point is secure, in other words, you need to be known, you need to log in, any HTTP traffic is vulnerable to this?
Short answer, yes. So even if you're on a local wireless network that is encrypted using WEP, or better yet, WPA or WPA2, you're secure within your little sphere there, your little bubble. But as soon as that traffic leaves your home router, goes out on Comcast or Verizon, then it's literally out there on the internet. Now, the odds of an adversary being between you and, say, Facebook.com, who's tapping into Verizon's network or Google's network or one of the intermediate routers, probably relatively low probability, if only because there's probably no one out there that cares about you specifically and your traffic specifically. But certainly if someone is just sniffing all this data in bulk, like a spammer, then you just become one of many, many victims. So yes, if you don't encrypt the data end to end, this is absolutely a vulnerable scenario. So how do you mitigate this, right? Facebook probably tomorrow morning is not going to go ahead and enable SSL. It would cost them a fortune. And most sites probably are not going to do it overnight. It would cost them a fortune. So what can you, the end user, do? OK, I mean, frankly, right, abstinence. Just don't use these websites if you're at all worried about your data or your account being compromised. 2. So you could VPN. So you can use a corporate network or maybe a university network like Harvard has, whereby you connect from your chair in Starbucks to Harvard or your company's VPN, thereby creating an encrypted connection between you and the company or Harvard. This mitigates the concern of having some random kid in Starbucks or nearby running this particular utility wirelessly and sniffing your traffic. But to be clear, that does not obviate which threat. connecting to a VPN between you and Harvard from Starbucks. Where are you still vulnerable? Just to reiterate. So man in the middle, really, or so in theory, yes, there is a man-in-the-middle attack whereby you could accidentally set up a VPN connection to some stranger. Lower probability, but possible. But to be clear, where else are you still vulnerable, even if you've established an encrypted connection to your own company or Harvard?
Between Harvard and Facebook.
Exactly. Once the traffic leaves that encrypted tunnel and goes out on the regular internet, could you be exposed again? At least there, your traffic is commingled with a whole bunch of very high throughput traffic and not just some random, a few thousand packets per second in the local wireless network. You're probably more at risk in a locale like Starbucks or your own home. But still, this is kind of the state of our world right now. But thankfully, there's a solution. This is not a hard problem. It just requires some attention and some money. Yeah?
Reports came out today after this was introduced that after Google introduced SSL for Gmail,
OK.
it only increased 2%. It only cost them 2% more CPU.
Oh, that's good. Interesting. So for the camera, apparently it only cost Google 2% more in computational CPU costs when they turned on SSL. I suspect this is the result of using various SSL accelerators. So actually, some companies have made good business of actually selling dedicated hardware that's particularly well optimized for the types of mathematics that's involved in SSL. So what a lot of websites, and we'll talk about this toward the end of the semester with our scalability lecture, what a lot of websites will do is they will support SSL. The traffic will come in, but to a dedicated SSL server or cluster of SSL servers. They then decrypt the traffic and then send the traffic along its way unencrypted to the rest of the company's web server. So we'll talk about this multi-tier architecture where you have these very front-end SSL servers. Behind them you have your web servers. Behind those you have your database or application servers. This whole tier, but you don't really care as much about the crypto inside your own LAN, at least if you trust yourself and your employees. So odds are that's how people can help make this happen. But for the typical case, when you're using like a commercial web host and your database and your website generally live on one single physical machine or virtual machine, generally that machine's running Apache or some similar web server that itself supports SSL. So when you turn on SSL in that environment, you then are making a trade-off between how many requests per second you can handle and how secure your websites actually are. Yeah? So yes and no. Could you commingle the cookie with your IP address? So that is true in that if the web server actually remembered that this cookie came from IP address 1.2.3.4, if it then sees that same cookie coming from a different IP address, it could just ignore it or reset the cookie. I would push back that in a scenario like that, it's very possible that an environment like Starbucks is using NAT, network address translation, so that to the outside world, me and the bad guy look like we're at the same IP address. And so that would be one immediate impediment to that. You could do perhaps more sophisticated things in JavaScript and partially encrypting just the cookie itself. But again, what's nice about SSL is that it already exists. It's off the shelf. It's a standard. Browsers support it. So hopefully, to be honest, I think we'll just get to that point before long. And a lot of this, frankly, I think comes down to familiarity, right? If no one in this room or a bunch of people in this room didn't really appreciate just how vulnerable you were when sitting on a Wi-Fi connection or even a wired connection, then what motivation do a lot of these companies have? Banks, literally have dollars to lose, and Google had a lot of bad press, and they at least understand the technologies. But a lot of websites don't care, don't know. If no one's clamoring for it, why bother? So we'll see. Maybe in a year we'll have a very different conversation. But don't tell me if you go and download this tonight. Don't use it on Harvard's campus, at least. All right. I'll admit, with some hypocrisy, it's actually frustrating how many access points in the world are now secure, because you try to sit down at like a Starbucks and find free Wi-Fi or whatnot. You just can't anymore. It was a different world a couple of years ago. Not that I would have ever, but I noticed these things. All right, so today is about JavaScript, but first a comment about MySQL, because there were a few questions on the bulletin board on the Google group recently. Dan did just field these because he and I decided on exactly how best to solve this problem. But a quick overview of what the cloud topology is that you've been connecting to. And this is not interesting because of how we specifically designed this cloud, but how it's pretty representative of a tiered architecture, which again we'll talk about in our scalability lecture. So when you SSH to cloud.cs75.net, this is actually a dedicated virtual machine in that it's running on physical hardware, which is running a hypervisor called VMware ESXi, which allows us to run this and other VMs on the same physical hardware. The specific VM happens to be running CentOS Linux, which is a pretty stable flavor of Linux, and it's running a special tool called HA Proxy. High availability proxy, which is wonderfully free and wonderfully high performing, in that this doesn't even blink an eye when we have dozens, hundreds of connections simultaneously connected to the cloud via HTTP and via SSH. So really, even though we use this in another course of mine, it really doesn't bat an eye. The load is pretty much negligible. What this software does for us is, as you SSH or visit via HTTP, the so-called cloud, we then have multiple back-end virtual machines that we refer to as login servers, as you may have seen if you poke around the host names. And what HA Proxy does is it randomly routes you to this server or this other server or any of the available virtual machines that we have behind this so-called proxy, otherwise known as a load balancer. And the idea here is that we can have multiple VMs to handle increasing load. We have multiple machines for redundancy in case this VM dies or we need to upgrade it, as we occasionally do. We can say, stop routing people to this box. Then we wait a few hours till people's connections die or they go to sleep. Then we upgrade this one. People automatically get sent to this one. Then we flip the process. So it's got some administrative upsides for us. But there are some implications, because what also exists on the cloud, now that we're at this point in the semester, is a database server. And mostly for simplicity and because we don't really need to have a huge amount of load supported, we have one virtual machine running MySQL and also PHP and also Apache HTTPD. So this is our so-called LAMP server, Linux, Apache, MySQL, PHP. And when you actually SSH to the cloud, you are indeed ending up at these login VMs. But if you visit the cloud via HTTP or HTTPS, you're actually routed by the load balancer around the login servers to this guy. We wanted to have all of these services fairly independent, both for security purposes and also just for administrative purposes. And again, it's just convenient for us, especially since we only have to support a few hundred accounts, to keep all of the databases in one place. But the implications of this are as follows. When you are writing PHP code for the course that now needs to talk to the database, you kind of need to know what's going on underneath the hood so that you're actually connecting to the right server. And one of the problems that arose on the Google group lately was that people were SSHing to the cloud, which meant ending up on one of these VMs. And then they would run the MySQL command line command. But by default, that command connects to the local host, which means the local server. But MySQL is intentionally not running on these login servers. Their purpose in life is just to be CPU workhorses, just SSH boxes. So technically, you could have typed MySQL space -h for host name space and then the name or the IP address of the specific virtual machine that's running MySQL. But we decided this is a little unnecessary complexity and it's not a detail worth remembering consistently. But what we did do was we gave this virtual machine a host name. It's called mysql.localdomain. We updated our DNS records throughout the cluster so that all of these servers know what that server is. So henceforth, per Dan's email, when you're writing PHP code that needs to call a function like MySQL connect, the name you should be passing in as the first argument is henceforth, quote unquote, mysql.localdomain. And the upside of this is that even if you're running your PHP code at the command line for diagnostic purposes or via the web, that host name will always resolve to the IP address of this virtual machine, no matter where you are in the cluster. And we also configured via standard file. You might recall that my.cnf is the name of the configuration file that MySQL uses. We added just 2 lines of config in that file to say that when you type MySQL at the command prompt, don't assume localhost anymore, assume mysql.localdomain. Because otherwise it would be very tedious if every time you ran MySQL, you'd have to run mysql-h, mysql ... just ridiculously tedious. Now similarly, to be clear, phpMyAdmin has already been magically configured to know about this host name. So this was really just a refinement when we realized some folks wanted to use the command line as well. And the only gotcha that I think is regrettable is that if you are among those who are using XAMPP on your local system or WAMP, one of these local LAMP stacks on your own machine, by nature of that running on your own laptop or desktop, the database there is going to live at localhost. So the one gotcha is that when you upload your code to the cloud, you'll probably want to change your constant or your variable to say mysql.local domain instead of localhost. So that was one wrinkle. We didn't feel great about it, but this was the most robust way we felt to solve it. As an aside, at least if you're on a Mac or a Linux box of your own, you can actually just fake this yourself. You can edit your own version of /etc/hosts, which is a standard configuration file, and you can say mysql.local domain actually resolves to 127.0.0.1, which is my own IP address. But if that sounds too new to you, don't worry about it. It's just one line of code you'll have to change when it comes time to submit. So we'll talk about these kinds of issues, to be honest, in scalability. We've probably over-engineered the problem for the size data set we have and the number of users we have, but it's pretty consistent with best practices, this idea of separating out the different tiers or the different services that we have, and the fact that we're virtualizing everything just gives us yet more flexibility. We can move things around. We don't have to buy new equipment. Looking ahead, to be honest, if you're responsible for one or more machines in your own employment, or find yourself doing a consulting project at some point, we've tried a bunch of load balancers, free ones, over the past few years, and HA Proxy is wonderful. It's just a few lines of code, and the thing just works. It's wonderful. So this is in contrast to some of the devices we'll talk about in a scalability lecture that you'll literally shell out 20K for, 50K for, 100K for, and they really are just Linux boxes with fancy logos and support contracts. Anyhow, JavaScript. So JavaScript is actually great fun these days. It's really matured from the annoying little language that it was just a few years ago, which we used to pester all of us with those annoying pop-ups with window.open, which is a function that still exists but is largely fallen into disuse. But it's an increasingly powerful language, and it is the language with which this technology called Ajax has been implemented. So you'll recall the familiar site like Google Maps, which we talked briefly about before. Most of you are probably familiar with it, or Yahoo or Bing Maps, whereby you can click and drag, for instance, and the whole page doesn't reload. There is no more of this 1990s style click up, click left, down, click right. Everything is much more dynamic. And this is an exciting time, I think, because especially in the past year or two, websites are really evolving into web applications more than they are traditional web pages where you have to click and then wait for the new content to come. They're really becoming more similar to what we know as desktop applications. So we'll probably see even more of this over time. What we'll do in this lecture and next week is really look at how these technologies are implemented underneath the hood, what Ajax really is, but then we'll quickly, toward the end of the semester, especially for final projects, encourage you to leverage various libraries that make it even easier to interact with these technologies and not have to code at a particularly low level. But understanding it for today is one of our goals. So what's really happening underneath the hood? Well, let me go ahead and open up our old friend Firebug. I'm going to pull up Google Maps again, click the little bug icon, and now I have this in my little packet sniffer here. Let me go ahead and just reload the page, just so I'm starting fresh. I'm going to clear the output here, and notice at this point in the story, the whole map that I can see has been loaded. So I'm going to go ahead and click and drag and see what kind of HTTP traffic is induced down here. Click, drag. And it looks like a whole bunch of requests. I mean, this is one of the interesting issues of scalability, too. That simple little click and drag that wasn't even precise on my human part, 15 HTTP requests, each one of which incurs some latency or some round-trip time to the server, not to mention bytes. So this is one of the reasons why sites on your phones these days just feel so slow, because odds are, whether it's a map or just some news site, they're not probably just making one request. They may very well be making 15 requests. So as increasingly being mindful of the design of your software and not just assuming, like many of us have gotten to the habit already, of infinite broadband bandwidth is very much compelling still. 3G really is not an impressive speed these days, and 4G probably not all that much more impressive. So it's going to be some time before we really have really impressive speeds, at least, well, sometime, a couple years at least probably. So with that said, what's really going on underneath the hood? Well, every time I click and drag, there must be some function, happens to be written in JavaScript, that's listening for this behavior. What's nice about JavaScript is that it is an object-oriented language, but it's also an event-oriented language whereby there's various events that you can listen for, one of which is click, one of which is movement, one of which might be typing on a keystroke. Pretty much any user interface, any user interaction, you can notice and then respond in some way. So it appears that Google Maps, for instance, is responding to a click and drag of the mouse by inducing one or more HTTP requests. And it's doing that via this technology that's generally called AJAX. And specifically, there's going to be a special feature of AJAX, of JavaScript, called XML HTTP request object that is the feature of JavaScript that allows you to make these HTTP requests behind the scene. But more on that in just a bit. First, some of the preliminaries. So JavaScript is actually, there's really no one good authoritative resource, to be honest. PHP is amazing, I think, in terms of the documentation that's available at php.net. It's nicely centralized. It's 100% complete. I've never really found as compelling a resource for JavaScript, so you pick it up in various pieces. Perhaps the most authoritative source is from Mozilla itself at that top URL there. But if you're the type who likes to read before you dive in, or at least kind of get a sense of the land, these are 4 references that we would recommend considering moving forward. And we'll make sure all these slides are already online on the course's website tonight. W3 Schools 2, we often recommend this one for all sorts of things in the course. It's not bad. Frankly, it's a little hard to read. They have way too much clutter in their website, but they at least have a lot of content there if you dig in and find the links. So same for JavaScript as well. So how do you actually code JavaScript? So the most important thing to realize, at least if this is new to you, is that JavaScript is a client-side programming language. It is not server-side, which means you cannot write JavaScript code that calls a PHP function. You cannot write PHP code that calls a JavaScript function. Now, those statements are correct if you take them literally. If you write your code in a certain way, you can write JavaScript code that induces execution of a PHP function, but only if that JavaScript function induces an HTTP request to a URL that ends in .php and therefore just so happens to induce execution of PHP code that returns some response that the JavaScript is waiting for. So it is incorrect to write some JavaScript code, as we'll start doing tonight, that uses the name of a PHP function. It just has no access to that on the server side. You have to go through this middleman known as HTTP. So do keep those barriers up in your mind. Now, where can you write the JavaScript code? Well, generally speaking, if you want to write JavaScript, whether it's to grab more tiles for a map, whether it's to pop up a new window, whether it's to get input from the user, really whatever you want to do with it, we'll look at form validation, for instance, today as one common feature. You can simply specify the script tag, the language in which you're writing it. There are alternatives, like for Internet Explorer, you can use like VB script and the like, but pretty much JavaScript is what's standard on the web. This syntax here is just to ward off confusion for the browser if you use a less than sign, for instance. Recall that less than is a dangerous symbol in the context of XML or XHTML. So this says don't try parsing any of the following data, just interpret it as code that can be executed. But in where I have the ellipsis there can go your JavaScript code. Where does the script tag itself go? Generally 2 places, either in the head tag of your web page or in the body tag of your web page. But where you put it rather depends on what this code needs to do. And as we'll see over time, it's very common these days to use JavaScript code to manipulate your page's DOM, the document object model, or really the tree that represents your XHTML. But there are some gotchas and some design decisions you need to be mindful of. If you put some JavaScript code whose purpose in life is to update the web page later on in the later down in the DOM, you can't put that code in the head of your page, because literally do browsers read your code from top to bottom, left to right. So if you start executing code before the browsers even notice that you have like a table tag down there, you certainly can't modify that table if the code is executed first. So code is executed much like tags, top to bottom, left to right. There are ways to mitigate this, but just realize that you do have to be careful when designing code. You have to understand that the DOM itself might not be loaded at the point in time this code is written. So case in point, how many of you have ever used Google Analytics for your own websites? OK, a few of you. Other examples, there's various social networking plugins like Facebook and Twitter have now to embed things in your website. Almost always do these sites say, put this JavaScript code at the bottom of your web page. And the simple motivation for that is they want to ensure that the browser has already rendered the rest of the DOM up in the page. There's also another gotcha. In the world of advertising, you'll see little flash animations here and movies and images and all of this all over the web page. Well, that's not generally the best design to put a script tag here or here, because also browsers tend to execute HTTP requests in series, which means if you've got an advertisement up here toward the top of your page and it's trying to access some GIF or JPEG at an HTTP URL, well, if that advertiser site is down or if it's being slow, that one request for some stupid little ad can slow down the loading of the entire web page because it's a blocking requests. Now, web browsers do make multiple requests at a time, but still, by bad luck, could you end up seeing a big white screen until that request times out or the ad actually comes down. So understanding the structure of DOM and the relationship of it to JavaScript really can impact not necessarily the performance of a web page, but the appearance of performance of a web page, because your site might be super fast, but you might have this one blocking call that's slowing everything down. And that doesn't have to be an ad. It can be for some CSS on maybe Yahoo's YUI site. It could be for Google Analytics itself. It could be for that fun Facebook plugin you wanted to add to your site. Anytime you're including other people's content in your page, it's good to be mindful of how that's actually being loaded into the document. So this, though, is the basic building block with which we can embed JavaScript code somewhere in the page. But there is an alternative. Yeah?
So JavaScript is an interpreted language, right?
It is.
So the interpreter is actually your browser?
Correct. So JavaScript is an interpreted language. The browser itself is the interpreter. And this is why some folks like Google with Chrome of late really like to harp or to brag about just how fast their JavaScript interpreter is, because one of the races going on now between Firefox and Internet Explorer and the like is to compete at the JavaScript level. Just how fast does JavaScript code get executed? And that's compelling because it's so much in vogue these days and so heavily used in websites. Case in point, some of the campus-oriented apps we've demoed in class for events and for courses and whatnot, I mean, those are hundreds of lines of JavaScript code. We're not just talking little snippets anymore that just pop open a window. I mean, it really is a whole application implemented in JavaScript, so the faster, the better. So there is an alternative. You don't have to put your raw code right there in your HTML file or your PHP file. You can factor it out, just like CSS, but there is a gotcha here. The upside of factoring it out is that now you can use that code on multiple pages. With high probability, it will get cached, which means the next time you visit this page, you won't have to re-download this file.js file. But there are one or more downsides, which might be what? What's the downside of putting code in a separate file like this, even if you know nothing about JavaScript? Just reason through it. Yeah?
You gotta be careful which directory you put in if you import it from machine to machine.
OK, certainly. So being mindful of relative directories versus absolutes is important, because if you want to move the website around, there's nothing more annoying than having to go in with a special command or manually changing all of your URLs just because you move something to a subdirectory. So there's that gotcha. What about performance? What might be a cost be to this approach?
The browser's going to go out and ask for that file as well.
Yes, right. So exactly. One of the themes tonight has been, look at how many HTTP requests we're already making. Here you are proposing we make yet another. So upside is, well, maybe we don't have to make it the second and third time because it gets cached, but that first time might delay the loading of our page initially. And why, to be clear? Well, anytime, Firefox is actually a decent visualization of this. Anytime you visit a web page, you get these HTTP requests. Every one of these takes some number of milliseconds. In fact, Firebug will literally tell us that this first request took 133 milliseconds. The next one, 51, 32, 41. Now notice that a lot of these are executed in parallel. That's why the times all line up in this way. But some of them are only induced later on, as you can infer from the sliding scale. And so it's really the aggregate amount of time that matters. For this page, looks like it took a total of 289 milliseconds to download everything. No, that's not slow, right? Generally, humans won't notice if it's less than 200 milliseconds. But this is still a lot of HTTP requests. And you're absolutely going to notice that on a slower connection. OK, so what's another downside of factoring something out into a JS file, potentially?
After the code changed, the browser still might be working on your cache.
Yes, you might have caching issues, to be honest. It might sound like a brilliant idea to factor out your code like this because you get, again, the caching ability, but that's a two-edged sword. If you realize, damn, there's a bug in my code, or we need to add a new feature, it might not be immediate that your users actually get that feature or that bug fix unless they quit the browser and clear their cache or force reload the page. So during development, if, especially now as we enter the JavaScript portion of the course, especially for the last project and final project, you as the developer will very often want to be forcibly reloading your page before you start coding. If you're using Firefox, you should absolutely pull up something like Tools, Clear Recent History, just to make sure there's no artifacts there. But this is one of the hidden costs. And so maybe the approach really should be use embedded code during development so you can ensure that nothing is getting cached accidentally, or at least be mindful of this as you're reloading and reloading your page. Now, with that said, you can actually tweak the server to actually spit out special headers that will advise the browser, don't cache this, don't cache this. A downside of this, though, is that you're then sacrificing one of the compelling features, which is the cacheability of it all. And as an aside, you will, at least if you take this route of doing somewhat non-standard things, generally browsers expect JS files and CSS files to be static. But a few years ago, this is probably moot these days because IE6 is dying off finally. But IE6 at least, if you sent a non-caching header along with a JS file, just everything would break altogether, and the JavaScript would not actually get executed. And this is one of these cross-browser nuisances that you have to be careful about, especially when you're trying to be too clever for your own good, which might apply here. So there's also this. Frankly, I'd say this is not found in too many websites these days because now it's very much a design decision whether or not to use or not use JavaScript. The idea of a website being able to gracefully degrade from a JavaScript version to a non-JavaScript version these days is kind of tough to pull off, given that these websites really are applications and they're not just JavaScript enhanced versions of websites, but you do have this capability. If you want to be able to have some JavaScript code, like something silly, write hello world into the document by calling this write function, just in case people don't have JavaScript support enabled or existing in their browser, the no-script tags contents will only get rendered if there is, in fact, no scripting language support in the current browser. So this was one way back in the day where you could have kind of two versions of your page built in, one between these tags, one between the others, or at least you could have a message here like, please enable JavaScript in order to use this site. So this is a common question that arises. Certainly at this point in the term, what should you assume of your users, right? A lot of you might be coming from environments where you kind of have to assume the lowest common denominator. What if the person has cookies disabled? What if the person has JavaScript enabled? If it's a compelling business or use case to support those users, frankly, it's kind of a nightmare these days because it means you really cannot use lots of features, or you have to implement your site the way you want and then have kind of a scaled back version that uses 1990s style HTML. And the biggest fish out there, like even Gmail has an HTML only version that they offer for people with very low bandwidth or just people who have JavaScript and the like disabled. But this is not fun. This is like building two separate products these days. So if it comes time for you to decide, should you require JavaScript, should you not, at least consider who your user base is. We have the advantage in an academic setting, certainly with lots of students on campus, that we pretty much assume people have fairly modern hardware, they have fairly modern browsers, and heck, I mean, we can expect those users to kind of rise to our level rather than our expecting that we need to support something as old as, say, IE6, which is kind of one of the canonical examples still of having to maintain backwards compatibility with a super old browser. So it's a tricky question, though, for some. All right, so what can we do with JavaScript? We'll dive into some actual code in just a moment. But just to assure you, this actually isn't all that dissimilar from a lot of the procedural languages that you might know already, whether it is PHP alone, or C, or Java, or any number of other languages. Some of the basics of JavaScript are rattled off here. So it's got loops. It's got some for loops. It's got a few variants of for loops that are useful in different contexts. We got while loops. We've got the notion of exceptions, try and catch. We have the notion of variables, whereby you can specify with var that here comes a variable, but JavaScript, like PHP, is loosely typed. You don't have to specify what the data type is you want to put there. It will infer from context if it's a string, a double, an int, or the like. What else? We've got switch statements, returning, conditions in the form of if and else. You can declare functions with the keyword function, continue. And this is a decent list of probably the syntax you would use most often. So this is really only to say that even though it might feel like, oh, I'm just now getting comfortable with PHP, well, it's not all that hard to now pick up this syntax as well. It's pretty much familiar in terms of functionality. So let's look at some of these features and then dive into some examples that use them. So one of the most helpful features of JavaScript is how it handles arrays and more generally something called an object. So in JavaScript, if you want to create a new array and start storing something in them, you have two different approaches. You can either declare a variable, let's say var a, which gives me a variable called a, and then we can call what effectively is a constructor. Although JavaScript is not a class-based language, it's what's called a prototype-based language, whereby you still have the notion of objects, but it's not quite the same as Java or object-oriented PHP. We'll see some examples over time. This first line returns an array. Frankly, the second syntax is just as valid and a lot more succinct. If you use square braces here, you can instantiate an empty array with just open square bracket, close square bracket. I frankly wish, my one biggest pet peeve is PHP, is that it's not as simple as this to create an array. You instead have to call the stupid array function to get back an empty array, which just adds clutter to one's code. This is pretty compelling when you can just get an array like that. How do you add elements to it? Well, same old way. If I want to put foo at location 0, bar at location 1, it's sort of the familiar syntax, although there are some tricks that we can employ. For instance, what's neat about JavaScript arrays is that they're really vectors. They're not arrays with fixed size. In fact, you did not see me on the previous slide specify a size for this array. So I can use this trick. An array has built into it in JavaScript a property. It's a read-only, well, that's not true. It's a read-write property called length. And length, by default, is going to be 0 after you have declared an array. To be clear, even though I've written these two lines, one after the other, assume that I'm picking between the first line or the second line. Calling both of them is kind of useless. So assume I'm choosing one or the other. Then I'm executing these three lines. Because a was just declared, its length is going to be 0. So this is equivalent to a bracket 0. But as soon as I add an element to it with that first line of code, this property called length automatically gets updated by the JavaScript interpreter. So naturally, this next call is a bracket 1, a bracket 2, and so forth. And if you want to empty an array, it suffices to say a.length equals 0. And that will free up what memory, or it will free up for garbage collection what memory was allocated for that particular array. You do not, much like PHP, you do not need to do memory management yourself, much like Java, unlike something like C or C++. All right, so let's put this to the test. This is a little more verbose than it needs to be in all contexts, but suppose I have the following code in a web page. The web page in question is our familiar login form, which has a form field for username and a form field for password. And one of the most underappreciated features of JavaScript is that you can add such marginally easy and yet terribly useful UI enhancements, whereby when you visit a web page and it's got a form, the cursor gets put for you in the default field. You don't have to move the mouse, click, and do the one thing this page is meant to be to do. You can use JavaScript to give focus to a given form element. So how do we do this? Well, we'll look at some code in a moment, but we can actually infer from context here. Document is a little similar in spirit to PHP superglobals. It's always available to you, and it represents the web page's DOM, document object model. Inside of document, document is an object, to be clear, and we'll look more at objects in a moment. But JavaScript objects can contain fields, and those fields can either be data, like in the case of can be data, as we'll see, and they can also be functions or methods that you can actually call. In this case, built into JavaScript, and more generally the browser itself, is support for document.forms. Forms is a property of this object called document, and forms is an object that contains all of the forms in this given web page. So the dot notation is how you access a property in an object. Similar in spirit, though the jargon is separate for accessing an array's length. So document.forms gives me the forms object in the document object. Document.forms.login gives me the login object that's inside the forms object that's inside the documents object. And we can continue with this logic. Username, meanwhile, is the object that's inside login, that's inside form, that's inside document. And finally, Value is just a field inside of the object called username, and that is where the string ends up that the user actually types into the so-called username field. So in fact, even though JavaScript doesn't have explicit types, there are different types. There are different types of objects. So in this context, it turns out that username is a string object. There are built into JavaScript certain, for lack of a better term here, certain classes, one of which is string with a capital S, another of which is date, capital D. So there are some built-in objects really into JavaScript. Strings are one of them, and strings have, among other things, values. So that first line of code, verbose though it is saying, is the value of the username field in the login form in the page equal to the empty string? And if so, what's the implication? Just in real world terms? Well, put the cursor there, right? That means I haven't typed anything yet. This is my starting point. Just put the blinking cursor there. How do I do this? Well, I start with the document object. I get all the forms. I get the login form specifically, the username field, and I call not a property, but a method that's associated with that object. And it turns out that a username, oh, wait, sorry, I misspoke before. Username is not a string. Username here is an input element in the DOM. It's a form element. My apologies. So here I'm saying take the form element called username and give it focus by calling this built-in focus method. All right. Otherwise, if there's something in that field, you know what I want to do? I want to give focus to the password field instead. I'm just assuming that in this case, if there's already something in the username field and I've just loaded the page, it's probably because some PHP code or some server code pre-populated the username field, as we saw the past couple of weeks. And so this time, let's give focus to the password field. So what's the end result for something like this? Well, let me go ahead and pull up, let's see, not this one. Whoops. Let me pull up form 1. Yeah, let's go ahead and do a quickie then. So form 1. So let me go ahead and copy form 1, and we'll call this form.html. Form.html, and let me pull this up in a browser, and then we'll write the code. CS75, lectures, 6, source. OK. So here we have a simple form. I'm going to go ahead and change this to username. I'm just basing this on another one we used a moment ago. Username, password. I'm going to get rid of this for now. And we have to give this name equals login. All right, so what do we have here? So if I reload this page, here's the page that I just very quickly whipped up for our login site. We have 3 form inputs, 2 of which are text fields, 1 of which is a submit button. But notice what I did there behind the scenes. I took care to make sure that my form doesn't just have an action, which apparently goes to some PHP page, doesn't just have a method, it also has a name. And it's this name login that actually populates inside the browser's menu the document.forms property that itself is called login. So where did that name login come from? It came from the actual DOM. It was inferred from there when the browser read in this page and then handed me this global variable of sorts called document. So we don't actually have any JavaScript code in there. So let's go ahead and grab that same code. So I'm going to grab this. I'm going to go into the, let's go into the file called form.html. And I could realize, put this in the head tag up here, but there's a problem. If I put this code in the head tag, per my warning earlier, what's the worry? Exactly. It might get executed. It probably would get executed before document.forms.login even exists, because the browser hasn't even gotten to that point in the story. So there's a few ways I can do this. One way would be, the simplest way, to be honest, is to go to the end of the file, sort of Google Analytics style, and I'd pretty up my indentation and such, but put it at the end after the close of the form tag, because at that point in the story, the browser knows that a form element exists, because it just saw the close tag. So now you can assume that that DOM element exists. And so now I can execute this code, and let's see if it's actually spot on. So I've made my name field called username. I got to change this. I got to make sure the password field is called password, not password1. Let's save, enter, and now let's go back to this web page, reload. Not working. Let's see what I do wrong. Always backfires if I do things on the fly, doesn't it? If document.forms.login.username equals 0, 0, let's put that. Oh, wait, let's see. There we go. OK, copy paste error. So notice the takeaway here is that I just hit reload on the page, and the cursor is already pre-populated, given focus to the username field there. Such a simple thing, but you'd be surprised how many websites don't actually do this. Now, how else could we do this? Well, just as a teaser, not to add too much complexity too soon, let me go ahead and erase the code that I just had in there and just point out one other way I can avoid this DOM issue. If I open up this form.html, and I insist that I want to put it in the head, or maybe I want to put it in a JS file elsewhere. The point being, I really want this to get executed up top, either inline here or in a separate file. How can I mitigate that concern? Well, you can do something like this. It turns out that some of you might have used the body onload attribute, at least in yesteryear, to trigger something to happen when the page actually loads. You can do open bracket body space onload equals quote unquote JavaScript code. Well, you can actually access that same idea in JavaScript itself by doing window.onload gets, and then onload is a property. It's meant to point to a function, so I can dynamically on the fly declare an anonymous function, otherwise known as a lambda function, that's really just a chunk of code that I want to give the name onload, so that when the browser looks at the property called window.onload, what's waiting there for it is essentially a function pointer. And that function will get executed. What does that function do? Well, it's enveloping all of my code here. So just to show you what the right syntax is here, let me scroll down. I would later close this function like this with a curly brace, and then I'd go through an indent to keep things nice and pretty. But now I've declared an anonymous function. I've bundled up inside some interesting code. I've attached it to the so-called onload event handler so that the page now executes this function. Now, there is one or more gotchas here, one of which is, what if I want two things to happen when the page is loaded? Well, I could just put it all inside this function. But what if I'm using some library like XJS or jQuery that itself needs to do something when the page loads? Here's where using third-party libraries starts to help. And what things like jQuery and YUI and the like do is they allow you to attach multiple things much more easily to something like window.onload. So generally, longer term, touching these low-level details tends to be suboptimal because libraries can help solve these kinds of problems. But this is what's fun about JavaScript. If you just need an anonymous function right now, bam, you can go ahead and do it. And you can attach things to properties like this rather easily. All right, so any questions about the onload handler? Or
does that get around the problem of the body of your document doesn't exist when the function executes?
oh, it does. To be clear, window.onload means only execute the following code once the whole window, the whole page has loaded. Sorry, I didn't make that clear.
Irrespective of where it lies in your
Exactly, exactly. Yeah?
I've been seeing document.ready. Is that just a jQuery?
Document.ready, yeah, that sounds like a jQuery thing. Other libraries use different syntax, and it's the same exact idea. They themselves attach to that property there, the onload property. Yeah?
So if you put the, if you refer to an external file in the header, that'll actually get executed before the...
It would, yes. If we factor this code out, put it in a .js file, we could accomplish the exact same thing. No.
So it will get executed before the document is loaded, or not?
It would. Short answer is it depends. So if you factor this code out, put it in an external JS file, the problem there is you essentially have a race condition of sorts, whereby the browser might very well fork off a thread to make that HTTP request to get the JS file. But if it's multi-threaded, it might proceed along its way, executing the rest of the page while it waits for these bytes to come back from the server. Depending on when they come back and when that thread is woken up to actually execute that JavaScript code, it's not clear if you're going to have hit that form element yet. So in general, it's absolutely best to code defensively and control the flow of your code's execution by using something like the onload handler. So in short, factor it out. It's kind of a roll of the dice.
So the onload, you can still keep it factored out?
Yes. Yes. Oh, that's a good question. That would actually contradict what I just said.
Well, I mean, I don't know if you can get onload to load an external file.
No, so actually, let me withdraw. So that doesn't contradict what I said. You can put the window.onload handler, or you can take like a jQuery-like or library approach to it in an external file. What's going to happen with some probability is that suppose it's slow loading this .js file, so the browser is going to continue executing the rest of the page, thereby building the DOM. So eventually it will grab that JS file. It's going to see this line of code saying only execute this once the page has been loaded. Thankfully, the page has already been loaded, so it's going to execute instantaneously. So it's fine to use something like window.unload in an external file. It just might immediately evaluate to true that the page has been loaded, if that makes sense. By page being loaded, I mean the HTML that was in the original DOM has been loaded, not necessarily these external files. All right. Catch me in the middle if I should elaborate. All right, so let's do one other thing here. So we have this old friend here that we started playing with in the context of PHP. Turns out we can do a lot of the form validation that we started doing in PHP using just JavaScript. And in fact, it's pretty compelling to do validation of forms in JavaScript as opposed to only server side. For what reason? Right? Yeah, anytime you make an HTTP request to a server, especially to ask such a stupid question, is this a valid username or password, which really should be such a quick answer, you're going to take a few tens of milliseconds, a few hundred milliseconds, maybe a couple seconds if the network connection is slow. And then if the user is just going to be told invalid username and password, then like, what'd you keep me waiting around for that long when you could have figured this out a little sooner? Not because their username and password is wrong, but what if it's a blatant syntactic error, like it's not even a valid email address, or I left the username field blank, or I didn't type in enough digits to be a phone number. Anytime that you don't need database access, but can analyze the data in its native environment and just say, that can't possibly be right, you might as well use some JavaScript for that. For instance, in a registration page these days, it's very common to see one of those strength meters. You get little red or yellow or green that says how good your password is. It's not asking the server how good your password is. It's just analyzing your code using something called a regular expression or counting the number of characters and punctuation symbols and the like. And then it's just showing you an appropriate GIF, green one or yellow one or red one or whatever, based on what it deems to be the strength of your password. That's all being done client side. Similarly, if you're asked to type a password twice, the website should be able to tell you instantly if you've typed the same thing twice or not at all, because if you haven't, why waste its time? Why incur server load, which costs money in a sense at the end of the day, if it can answer that question right away and spend your CPU cycles, not its own? So in this case here, you can imagine a few opportunities when a user is trying to submit this particular form. We can make sure that, one, all the fields have been filled out. So that's kind of a no-brainer, a feature that we would probably like. We probably want to detect what other features with this form in JavaScript. That it's a valid email address. There better be an @ sign in there. Maybe we could be as anal as to say it really has to end in .edu, maybe if we're trying to restrict this to academics. Or we could at least look for some familiar TLDs like .com, .net, .gov. Gets a little sticky if you want to support country codes. You might not want to have a huge list of 100+ country codes. But we could look at the structure of the email address. This one's easy, right? This third field better be the same as the second field. And then this box feels like it's got to be checked in order to let the user proceed. So how can we go about doing this? Well, there's actually a few different ways, and frankly, there's dozens more that are possible, but we'll focus here on some of the features with which we can implement this. So this is form1.html. It actually looks pretty much like the screenshot we saw a moment ago, and it looks a little something like this. And I'm going to go ahead and be an adversary who's not going to cooperate and not going to type in what's being asked. I'm going to click Submit while sniffing my traffic with Firebug. And now we see on the server side exactly what was inputted. Now, what does process.php do? Notice that I just submitted to process.php just for some diagnostic purposes. This is a little couple-line PHP script that just dumps out the contents of what, does it seem? Post? What's that? It's not post, and you know that why. Yeah, because we see these parameters in the URL, so it must be get, $_get, or maybe $_request, which is a combination of get and post and cookies. So feels like it's just get or something like that. And it's just dumping out the contents. It looks like I'm seeing a PHP sesh ID because at the moment I'm on cs75.net, and I previously was on the course's homepage, which does in fact use sessions and a cookie. And so I'm just seeing an artifact from having visited the rest of the website. If I go back and, like a good developer, go to my recent history, clear it, and now resubmit this with just some garbage values here. Now, in fact, I don't see the session ID because I've not visited the course's homepage. So now it's a little cleaner. All right, so it feels like there's definitely an opportunity to validate this form before we allow submission to proceed, because at the moment, this form is not doing any such sanity checking. So version 1, form1.html, really does nothing. It just lets the data through. But let's actually add a bit of client-side validation. So I'm going to scroll down here, and all of these files are available already on the course's website for after class. It's a little long and ugly because font's kind of big, and I kept things on one lines for some of the longer lines. But what do we have here? I'm inside my head tag. And even though I had a problem before with the idea of executing code right away in the head section, it's not a problem if you just want to declare and define a function inside the head of your document, because that function, like in PHP or most any language, is not going to get called unless you yourself call it. It's one thing to define and declare a function. It's another to actually invoke it. I'm not apparently invoking it yet. The syntax with which you declare functions in JavaScript is pretty much like PHP. Keyword function, the name of the function, and then a comma-separated list of the arguments to the function inside of parentheses, which in this case are none. So we can infer from the last example how this thing works. If document.forms.registration, okay, pause. Registration, what is that? Must be the name of the form. So I must have consciously added name equals quote unquote registration on the form, just as a matter of good practice, because if I had a bigger, more complicated page with multiple forms, I'd want to be able to distinguish among them. So giving it a name with the name attribute in HTML allows me to actually refer to it now in JavaScript. There are other ways of doing this, but I'm kind of doing it the very deliberate approach first. So if document.forms.registration.email, pause, what's email? Must be the name of an input field. So here's where the name attribute is again proving useful. Name email.value. So this is the actual value inside of that field. Equals quote unquote. Well, let's yell at the user. Let's specifically yell at them. You must provide an email address and then return false. All right, let's not look at the other conditions just yet. Let's ask ourselves, where is this return value going to? So let's ignore the conditions for a moment. Scroll on down to the actual HTML, and there's actually not much. This is a pretty darn simple form. I've got a form with an action. I've got an ID, which actually gives me that same capability, but a unique capability, so that I can access that property. And this will give me another, there's another way, a slightly easier way of getting at this form later, because I'm using ID and not just name. Method is get, but here's the interesting thing. There's this rich list of event handlers that come with modern HTML that you can attach JavaScript functions to. In this case here, onSubmit does what it says. On the submission of this form, execute the following code that's in quotes. What's that code? It looks like return validate, semicolon. So it's one line of code. Because of the semicolon, I could have multiple lines there, but the first should not be return if it's multiple lines. Validates a function I wrote a moment ago. And what happens is, according to the spec, if an onSubmit event handler returns true, the browser should let the form submission proceed. If it returns false, it should short circuit it, and the form should not be allowed to proceed. The idea here is that I'm going to instead see that alert message from my validate function, and the form submission is going to stop right in its tracks. Before we tease apart some of the other conditions, why don't we go ahead and take a 5-minute break. All right, so we are back. This is what I think they call shameless plug, but the Extension School is trying a new pilot program this January because the university at large has been experimenting with January terms, sort of a short opportunity for shorter classes, both at the college and at some of the other schools. So the Extension School is doing something similar where these aren't multi-day, multi-week, or multi-month courses. They're really 1 or 2-day classes as part of this program in computing and management in January specifically. So if you might find things of interest, just know that I'm going to be leading actually a 1-day class of sorts on cloud computing that's both conceptual and also hands-on. We're going to use something called Amazon EC2, Elastic Compute Cloud, to actually get our hands dirty with, frankly, some of the stuff we've been talking about here on the board, virtualization and virtual machines. And this very overused buzzword these days, cloud computing. We'll actually break it down into more interesting technical terms than it's generally used. Well, there is, if you have friends who want to take a pick up a bit of Ajax and LAMP. We're going to be doing this course, E75, in one day, really fast. Really just an overview, but a hands-on overview of what it means to do web-based development using LAMP and using Ajax. So if you have folks who you just think need to get a bit of exposure to this, know that that's an opportunity. I'll put the link to this on the course's website under lectures by tomorrow. But then there's some other courses, 1 or 2 days available here on social networking, privacy security, data visualization, trends in software security, relational databases. So these are really meant to be intense 1 or 2 day opportunities to just really get your hands dirty or your minds dirty with some interesting information. Perhaps take a day or 2 off from work accordingly. So coming this January if of interest. All right, back to JavaScript. Any questions about where we left off just a moment ago? Calling a validate function from an onSubmit event handler. All right, so let's see what more validation there actually was there underneath the hood. So we looked only at that first branch in my if condition a moment ago. Well, what else is actually in there? Well, it looks like if document.forms.registration.password1.value equals the empty string, feels like the user didn't enter a password, so let's yell at them for that. You must provide a password, return false. So that one evaluates to true. So now notice the theme here. I made the conscious design decision to only yell at the user for one thing at a time. You could certainly keep track of all of the things that they did wrong, maybe store the answers in an array of some sort, and then yell at them with a big paragraph saying all of the many things they did wrong. I made the decision to, 1, keep it simple, but 2, what user is going to spend time reading through it all, making a mental note as to how many corrections they need to make, and then go make them? I figured 1 at a time is actually a decent feedback loop. So in this case, if they provided an email address but not a password, I'll yell at them for the latter. But notice the top. I have not done any kind of syntax checking for an email address. I'm just checking if they typed anything there at all. So we'll iteratively improve this. So we're actually using some kind of regular expression, some kind of pattern to see if the user is at least giving me something that looks like an email address. So this line got a little long and ugly, but the idea is simple. If document.forms.registration.password1's value does not equal password 2's value, then the implication is that they did not type the same password twice. So I'm going to yell at them for that. Else, if they did type the same thing twice, but bang for not, if it's not the case that document.forms.registration.agreement is checked, then I want to similarly yell at them for not checking the box. So here too is another built-in property that you would pick up from a manual, from a course, wherever, that just says that if you have an input of type equals quote unquote checkbox, then it will have, according to the spec, a property associated with it called checked. That's a Boolean flag that says yes or no, true or false, this checkbox was checked. And so at the end, that's it for this function. If we scroll down, it's going to return true otherwise, because if it makes it through that gauntlet of checks, it's going to be, in fact, a valid form, at least in this current version. And so the form proceeds. So let's see what's actually going on here. I'm going to go ahead and go back to this version here, which is form2.html. Reload, and I see aesthetically the same thing. I'm going to reload again just to be super safe. And I'm going to just type in foo, bar, baz, nothing. Submit. What should I see first in the way of errors? What's that? So not email, but password1, because I did not, sorry, not password1, the password1 not equaling password2, because I typed bar and baz according to what I said. Submit. All right, so this is a bit of an old school approach, admittedly. The alert box is generally frowned upon for a few reasons. 1, it always looks a little different in browsers, so in terms of providing a consistent experience, it's perhaps suboptimal. Some browsers like Firefox also say this stupid tagline, the page at such and such a URL says, which frankly just is not the nicest presentation of content. It's also at the very top of the screen, which frankly on a big monitor might be big to miss. But for now, it's easy. There are other mechanisms, generally involving libraries, with which you can trigger what looks like a modal window, a window that steals focus and forces you to interact with it. But for now, this is what's built into JavaScript, and it's at least very easy to call. So let's cooperate. I'm going to provide the same password twice, bar and bar. Now I submit, and I get a different message. You must agree to our terms and conditions. All right, let me go ahead and check that box. Click Submit Now, and it lets the password through. But notice what's actually submitted. What value gets submitted, apparently, when you check a box? So on. Interestingly, what gets submitted when you don't check a box? nothing. So this is actually kind of a minor headache when it comes to writing code where you want to detect if a user has maybe checked some boxes or not checked some boxes. It is not sufficient to iterate over all of the keys in get or all of the keys in post, because they're apparently not going to be there necessarily. They're only going to be there if the user provided some value, like actually checking the box. So this is to say in project 2 or project 3 or beyond, if you actually want to compare what the user's input is against some canonical list like in your database, the for loop you're going to have, or the while loop, had better be iterating over data on the server side, looking for that key in get or post, as opposed to iterating over what's in get. Otherwise, you won't necessarily know what fields you provided to the user unless you're maintaining that information on the server side. In short, don't trust the user's input. Yeah, that's it. End of sentence. Don't trust the user's input. Always compare your records against their records here. Now, on, frankly, is a little bit arbitrary. In general, you could say, does the input in your PHP code, you could say equals equals on, but it suffices instead to just say, is this field set or not set, or is it true or not true? Because if there's not a browser that returns off as the value there. It's either on or essentially nothing. So you can infer an implicit Boolean value accordingly. Yeah?
So where does the false error message come from? Is that built into the browser, JavaScript?
The false, so it is. So if I go back to the code here, when I call the function, and let me move this onto a separate line for clarity, the onSubmit event handler is supposed to return a value, true or false, by definition. So that means my code has to return a Boolean value, true or false. So in this case, if I return false, it's programmed. The notion of an onSubmit handler is programmed to short circuit the form submission if false appears in those quotes. It really boils down to that. Other questions? Yeah?
The checkbox, would there be a way to control if it weren't checked? You tested for it, you set it to off?
Absolutely. Is it not checked? So we could, let me scroll back to my function here. I could say this. So what's nice is in JavaScript, even though it's not strongly typed, this is in fact a Boolean value. So even though what PHP sees is on or nothing, checked is a Boolean field. And so you can actually compare true and false here. So I can say if checked equals false, this is identical to what I just did. Or if I want to yell at the user for true, for instance, suppose perhaps a little silly here. Don't check this box. I'm not sure why you would do this, but I can now detect if the user has checked that box by saying, does the checked property equal true? And then I can yell at them accordingly.
Could you force the get value to be set?
Oh, OK, so let me actually scroll back to what's intended there and do this. Let me do a quick sanity check myself. So if I scroll down here, notice one property we've left off here is value. Let's call this hello. Let me go back to my page, form 2, reload. Oh, and notice this too as an aside. At least in Firefox, reloading a page, at least with Command R, tends not to clear form values, even though it might very well have refreshed the page. So you generally want to hold, in most browsers, Shift reload to actually start fresh. Minor nuisance there. It's supposed to be helpful. So let me do foo, bar, and then the checkbox submit. And what I get now is the preordained value. So it's only when I omit it that I get some arbitrary value, namely on. But in this case, I can hard code value equals hello, and only if the box is checked will hello get transmitted. Was that the question being asked? Yeah.
I wanted to transmit it in any case, so whether it was checked or not.
In that case, short answer, no. It's not a guarantee. You would have to use, not really, you would have to jump through a minor hoop, and actually in Java, what you could do is, and this is somewhat hackish, what you could do is, for instance, have an input type equals hidden, which has a name equals secret, whose value is dependent via JavaScript on whatever was in that other checkbox, and this just gets messy quickly. Better to check more robustly on the server. Other questions? Yeah.
What I thought the question was whether you could assert it to default to checked, which seemed like what happened when you had the value set. Like when you reloaded it, the check box was already checked.
Oh, value equals hello. Back here. No, it was blank. Yeah. But in answer to your question nonetheless, yes, you can say checked equals checked. This is an artifact of a sort of poor HTML decision. Back in the day, and still now for HTML, you can just say checked, for instance, but this is not conformant to XML, which requires that any attributes actually have values, which means you need the quotes, you need the equal sign, which means they realize, all right, we got to give it some value. Let's give it a value equal to its name. So it looks a little silly, but now if I reload this page, the checkbox is in fact checked. And there's one other feature we'll see in a moment, which is actually increasingly used for user feedback. You can also say disabled equals disabled for similar historical reasons. That means the checkbox isn't even checkable. But programmatically with JavaScript, can you re-enable something and then disable it? So if you've ever been to a web page that doesn't even let you physically click the button unless you have actually checked some box or filled out all the fields, we'll do that in just a moment with some JavaScript code and re-enable what's currently a disabled field. Yeah?
Can you change the type on an input? So if your input type is text, could you change it to be password, depending on a specific instance?
That's a good question. Short answer, I don't know. I suspect you could certainly change the value of that attribute. I don't know if the spec dictates that the browsers need to adapt immediately. So I would personally, we could certainly try this out on all sorts of browsers. Personally, I'd be wary because I feel like that's the perfect kind of thing that at least one browser doesn't behave properly. And so a password would end up in the clear. So I'd beware. Better in that case, well, more reliable, although maybe this does work, just never done it. More reliable would be to have two different fields and then use CSS and JavaScript to hide one or the other, but actually show a field that's been rendered properly. That's at least what I'd do, at least in the interest of paranoia. All right, so let's look at a slightly better variant of it. Well, let me point this out. This is not a commonly used feature, but at least to mitigate the verboseness of the previous example, felt a little stupid to keep saying document.forms.registration, document.forms.registration. So JavaScript does have this keyword called with. Frankly, I feel a little disingenuous because I don't think I've ever used it except in this example, whereby you can add to the current scope an assumed prefix. So what I've said here is with document.forms registration. That means for any parameter, any properties in the code that follows, assume an implicit prefix of this thing. Frankly, there's easier ways to actually shorten this notation, but if you see the with keyword, this is the context that it can be deployed in. But let me point out this other approach now. So in form 2, I'm going to go back for just a moment. Recall that my form wasn't given a name, it was given an ID. This ID was similarly used by the browser to uniquely identify the form. So with no change in behavior, I could still say document.forms.registration. But I did promise that we can actually get at this form a little more succinctly. So just so you've seen this, and this is what, frankly, a lot of libraries like jQuery and the like really leverage. If any element in a DOM, whether it's a form element or a div or a span or an anchor, whatever element it is, if you give an element in a DOM an ID attribute, first of all, it's up to you to make sure that it's a unique ID. The whole point of an ID attribute is it should be globally unique in the whole file. So you can't give two things the same foo ID. But if you've taken care to give everything unique IDs, built into JavaScript is this function, document.getElement by ID, and you can say registration. Unfortunately, in this case, I chose a fairly long word. It's not all that much more succinct, but this function call returns the DOM element that's identical to the longer, more verbose approach that I have one line down. So document.getElement by ID literally does what it says. It finds the element in the DOM, whatever the tag is, and returns that node to you. And then you can proceed to use your dot notation to access any properties within, and so forth. In jQuery, what you'll see, and again, I mentioned jQuery only because it's probably the most popular JavaScript library these days, enough so that people tend to conflate jQuery with JavaScript these days. You can essentially do neat notation using the $sign operator, where you can just get at an element by typing $sign and then essentially its name, sometimes coupled with some quotes or some parentheses, depending on whether you want to get it based on style, class name or style or its ID. But for now, we're doing it old school. Yeah?
So you could use this to get at something regardless of whether you get a form or not.
So that's true too, right? So I've been leveraging the fact that there's this global forms object called forms, inside of which is all the names of the forms or IDs of forms I've used. But document.getElement by ID lets you grab arbitrary elements in a DOM. which is quite neat. What's really neat too is there exist library functions and also built into JavaScript the ability, for instance, to get nodes by other properties, by classes. So for instance, we'll see in a moment that I will resurrect that nasty little tag called the blink tag by taking advantage of a function that will let me find all instances of the blink tag inside of a document. But using libraries, can you also get all of the elements in a big array that might have a certain class associated with them? You can remove classes, add classes. So even though thus far we've been using HTML and PHP and CSS, now with JavaScript you can start to tie together CSS and HTML or XHTML even more fluidly, and you can use them in a lot more compelling ways than than you might have thus far using them separately. All right, so with keyword, let me fast forward past that because that was just a syntactic detail. This one's more compelling. So this time I decided that, you know what, why do I have to hard code the path of this form? Let me try to generalize my code a little bit and take as input the form that I want to validate. The idea being here, I can use the same function, theoretically, to validate different forms so long as they have the same field names. Now maybe this is a little naive because why am I going to have a registration form in multiple different contexts? But at least the spirit, at least let's believe for the moment, is compelling, which is that I want to actually take as input the form so I don't have to assume which form I want to validate. So I can do this as follows. I can define the function validate is taking a parameter f. Notice I don't specify the type. I just give it a name, f for form. Could have called it anything. And now this is pretty compelling. Now I can just say f.email.value, f.password1.value, f.password2.value, and so forth. Well, how do I actually pass in a form in this way? Well, it turns out, in as much as JavaScript is object-oriented, notice that I can do this. Here is my form element. I actually don't really need this name anymore, so I'm just going to get rid of that. But notice my onSubmit handler. I'm returning the return value of validate and passing an argument of this. So those of you coming from an object-oriented background will know that this is generally a keyword that's self-referential to the current object in question. In this case, the object in question is the tag, the element whose open bracket is to the left, whose closed bracket is to the right. So when I say this, it's referring self-referentially to this form element. And it's effectively passing in a pointer or a reference to that current DOM node. And so now I get the reference in the context of the validate function, and I can navigate it just as I was doing before. But now in theory, I can pass in different form objects or references to different form objects and use the same code on them, at least if these same fields exist in that form. So it's a nice marginal improvement, especially when you want some dynamism. You want one function to be able to process multiple nodes, and you don't want to have to hard code the names and the full paths to those things. All right, so how about let me move on to form 5. Fifth variant. Finally, it's getting a little more interesting in terms of UI. So this is going to use the disabled property of the element, which prohibits us from actually checking it. So I'm going to pull up form 5 because this one's actually functionally different now. I'm going to reload. I'm going to just zoom in. And notice I can click the checkbox, but what could I not click a moment ago? The submit button. So by default, can't submit this form. It's not even letting me. But if I check this box, it will actually let me. Now you should be careful here because there are some gotchas with regard to accessibility and the like. If you are just taking it upon yourself to disable form elements, you better be sure that your user base, whether they're using their own mouse and keyboard, or if they're using a screen reader or the like, can actually interact with the remaining form elements there. But if that is indeed the case, realize that this is a useful mechanism potentially, so long as your audience understands what's going on, that this form cannot be submitted unless that checkbox gets checked. Now let's push back here. What might be, accessibility aside, be a downside of this approach, the disabling outright submission of the form until the user checks the box?
It's kind of mystery meat navigation. There's no affordance. There's no visual affordance that tells you that that's what you have to do in order to get it configured.
Yeah, this kind of assumes some amount of sophistication that checking that box, which frankly, especially now that I enlarged the font, is kind of like literally way over there, actually has some kind of relationship to the thing that's way over here. And there's no textual explanation that you must, it says I agree to the terms and conditions, but it doesn't say you must check this box in order to submit, which might be a little more clear. I mean, frankly, I can think of a few friends and or relatives who would not realize that there even is this technology that allows you to prohibit submission of a form until a checkbox is checked. But again, if you can assume that your audience is more technically savvy, this is actually a nice way of just raising the bar and helping them help themselves not submit the form prematurely. It won't even let them do it. But for our purposes now, no judgments here. Let's see how we would actually implement this. Well, I'm going to scroll to my head again here of the page. Notice I've got a script tag and the C data. And at this time, I've got two functions defined. Many different ways I could implement this. But conceptually, I wanted a function whose purpose in life is just to toggle that submit button, which means turn it on or turn it off based on its current value. And then I've got a validate function, which does stuff similar to last time. So what's the toggle function doing? Well, if document.forms.registration, so I kind of regress to the older syntax. If document.forms.registration.button, what must button be? Yeah, it must be the name or ID I gave to that button. It's coincidentally also a type of a form element, but it also could be the name, which I have full control over, if .disabled. So that too, like checked, is a Boolean property that is going to be false or true. So the fact that I'm just asking this question parenthetically in a presumed Boolean context is going to return a value true or false. So if it is disabled, and .disabled is true, then that first line of code executes. And what do I do to that property? I set it to false, right? So if it's false, I set it to true. Else, I set it to true if it was false. And as the name of the function implies, this toggles the state of that box. Now, who calls toggle? So let's reason through this before we look at the code. Where in my page should I actually call the toggle function? When I check the box. So thus far, I don't want to do it on submission. And yet, thus far, we've only seen the onSubmit event handler. So it feels like we want an onClick event handler. Like when I click that checkbox, call this function toggle. And sure enough, there's a couple of ways we could do this. Let me scroll down to the answer. What I have here is, yep, I agree to the terms and conditions. Let me move this onto a new line for clarity. And in fact, there is an onClick event handler. It does what the name implies. When I click this form element, it calls that function there. And notice I don't have to return anything, because I'm not talking about form submission. I just want to induce execution of some function, namely toggle. So I call toggle. It then checks the value of the form button and then toggles it accordingly. But I don't get to the point of form submission. But the way these forms work is if you have disabled your input type equals submit element, the form by definition will not be submitted, even if the user tries to. If you re-enable it by making disabled not disabled, then it will allow submission of the form. So use this perhaps with caution, but in some cases, certainly with limited demographics, it's certainly a compelling feature. But for our purposes really now, what's interesting is how you can implement something like this by checking the property. So that was form 5. In form 6, we can do it a little more cleverly. So again, I have the validate function. I've just been copying and pasting, so I have some validation going on. But notice this. Again, it wraps along onto multiple lines. And just to echo, I think a comment I made a couple of lectures ago, now that we're coding client-side and server-side, but in the context of web programming, I certainly don't adhere personally to the whole 80 columns approach of text anymore. I actually think it makes code less readable in this context, where by nature of the beast, you have longer lines of code. This wrapping is actually a little ugly in my mind, partly exacerbated by the font size here, but at least be consistent with your code, some form of style. So it turns out you can have inline JavaScript. I don't have to call a function, and it's not really warranted to call a function if this is the only place I'm using this functionality. So notice what I deem here an interesting one-liner. Here, my onClick handler is not a function call. It's actually a line of code, which is totally legit. You can argue the merits or demerits of actually embedding the code right in here. But for now, let's just see what it does. Document.forms.registration.button.disabled gets the opposite of that. So it's kind of a neat logical thing to be leveraging here. I don't need to check with the if and the else. Just flip it by negating its value. And if it's a Boolean flag, using the bang symbol, the exclamation point, will invert the Boolean value. Yeah?
How does it know that it's JavaScript?
Good question. How does it know that it's JavaScript? Because that's what goes in between the quotes after an event handler like this, a scripting language. And if pretty much JavaScript is the scripting language, though in other browsers like IE, you could put other snippets and things like this. But short answer is just because. That's the way the web is now working. Other questions? Yeah?
What if you have more than one instruction you want to run?
That's OK. If you have more than one line of code that you want to run, just separate those statements with semicolons. And at that point, frankly, I'd probably start to get a little uncomfortable, but you can do it with semicolons. Uncomfortable because then I'm really going to start wrapping in lines of code. Feels like I just want to clean that up with a function. All right, so that was form 6. Can we do even better? So we can, at least with the context of email addresses. Let me go ahead and pull up form 7 here. So in form 7, I have this example. So now I have, let's say, foo, bar, and now I'm going to check that box and submit. Ooh, it finally got smarter. You must provide a .edu email address. So how did it know that? Well, this is not, as I'll disclaim now, the most rigorous of regular expression checking. As you might have seen already with Project 2, if you actually dig around for the RFC for email addresses, it's actually a scary definition for what an email address could be, even though the world generally relies on just a few canonical forms. I at least went with a decent heuristic here to at least catch the real obvious mistake. So how did I do this? Well, let me just shrink the font this time to make this fit a little better. So now this is my validate function. And notice that I'm calling document.forms.registration.email.value and here's what's neat. So value, so earlier I called the wrong thing the string. Value is a string. And what's nice is strings have properties associated with them. And those properties can be methods. They can be function pointers, essentially. So value.match is the result of taking a string object, calling the method called match. And as the name implies, it tries to match that string against a thing called a regular expression. Now, regular expressions in JavaScript, for annoying reasons, frankly, look ridiculous. In almost any other language, you would actually surround this with quotes because it's a string of sorts. In JavaScript, you actually don't. You just put slash and slash inside literally the parentheses, and then you put your regular expression. So similar in spirit to what you've seen with preg match and in Perl regular expressions, but no quotes. It's a little weird. But what does this say? Can anyone translate to just normal people English what that regular expression translates to?
Well, the dot represents any character.
Okay.
Plus is some modifier for the number. So I'm guessing that's 1 or more.
Perfect. So dot is any character. Plus is 1 or more of any character. Good. Followed by
You need an @.
@.
And then again, the dot, 1 or more.
Dot 1 or more.
And then followed by a literal dot.
Literal dot.
Saving it. So, and then the string edu followed by end of line.
Perfect. So the $sign means match all the way to the end of the line so that the user could not have like dmailin@harvard.education. You have to actually end on .edu as denoted by the $sign there. Now, can someone propose a string that would actually validate, even though it's obviously not an email address? Yeah.
Just like @Harvard.edu.
Nice. At harvard.edu or at.edu, right? So that would pass validation because I've got at least one @sign preceded by 1 or more somethings, followed by 1 or more somethings, followed by or ending in .edu. So again, this is very sort of quick and dirty pass, but at least I can do a little sanity check and keep out any of the .com people, the .gov people, anyone who at least does not type .edu. Doesn't mean it's syntactically valid, but it at least catches some percentage of the use cases. Now, if you've started playing with regular expressions for the purposes of Project 2 or might for Project 3 or your final project, you have a lot more expressiveness. But there's this trade-off between, frankly, clarity of expression and the amount of time it takes to craft a perfect expression. And as some of you have noted, frankly, this is a good job for libraries, where let someone else think through the formal definition of an email address, and let me just call that person's function that they wrote for me. All right, so what more does this one do? Regular expressions. Yeah, so that one, that's it for the regular expression there. So I had a thought in just a moment ago, but it is gone. So any questions about validation? OK, so a few more details then on JavaScript and a few more tools for one's toolkit. So with regular expressions, there actually are, there's a whole class of sorts, a JavaScript object called regex that has some more powerful capabilities built in. So for instance, the string object .match method is not the most efficient way of invoking a regular expression, especially if you're doing it multiple times. Regular expressions are wonderfully useful if you're doing pattern matching. Case in point, if I ever pulled up on the event site. There's kind of an auto-completing text field. The way that works is it very rapidly, using linear search, looks through all the results using a regular expression, trying to match that current string out of the 100 or 200 strings in the list against what the user has typed. So in that context, I actually make use of the regex object, which has a compile function, which actually optimizes the regular expression matching process so that you're using ultimately fewer CPU cycles. That's useful if you know you're going to be using this regular expression again and again and again. And here too, there's this hint of this idea of the performance of JavaScript interpreters really mattering. If you've got a large data set, which you do underneath the hood with something like Google Maps, if you've got hundreds of events all stored in JavaScript and you need to search through them constantly to create the illusion of an immediate autocomplete feature, the faster your code runs, the better the user experience is going to be. And so there are some underlying mechanisms, at least with regular expressions, to optimize your code. With the string class too, there's some other functions there. Let me go ahead and pull up actually one of our old friends here, W3 Schools JavaScript string, just to give you a sense of some of the capabilities. So this is when this site is useful, when you just get a nice authoritative list of the built-in functionality. This is the so-called string object. And you see some methods here, one of which we used. We used the match method, but notice there's the char at method, concat method, search, slice, split, substring. So JavaScript, like PHP, has a lot of built-in functionality, and it's almost always methods associated with objects as opposed to sort of globally available functions like in PHP that you call just by their name and then pass arguments in. JavaScript is much more an object-oriented language in that regard. So what more can we do with this tool? Well, there are yet other objects besides regex and string. So we looked briefly at array. Boolean is actually an object that we've been using, albeit implicitly quite a bit. There's actually a function object which we've been using. There's a math object, which is actually quite useful for rounding and floor and ceiling, those kinds of functionality. Object, we'll see in a moment, is one of the most versatile ones, but string is perhaps one of the most common. And also date is actually wonderfully useful if you actually want to do anything involving dates. Yeah?
You mentioned the regex object has a compile function that kind of caches values to make it faster. Is that cached on the client side?
On the client side. All of this is client side.
So the very first time they search, it's just as slow as it would be ever?
Well, not so the first time. So not so much. The price you pay for using this compile function is the compilation time involved on the client side. Thereafter, the regular expression application is pretty quick. So that's why it's a trade-off. You don't want to call the compile function on that object if you're just using it once, because you're going to spend more time compiling it than you will actually running it. But if you're sorting through lists, generally of dozens or hundreds of elements, then you can amortize that cost over multiple executions, which is a good thing. So an object in JavaScript is like an associative array in PHP, or more generally is a map, or more generally is a hash table. It is just a structure into which you can put key value pairs. So it is perhaps one of the most versatile data structures in most any programming language because you can use it in really any manner you see fit, and in theory you get constant time lookups. Not quite true, but at least underneath the hood, if the data structure is implemented intelligently, it's pretty darn fast. It's not, for instance, like a long linear linked list. So the syntax for actually having objects in JavaScript are like arrays twofold. You can create a new object literally by calling the new keyword followed by the object name, open paren, close paren. That effectively means call the constructor for an object, which returns an empty object. More commonly, though, is this syntax here, open curly brace, close curly brace. What you really see this JavaScript object notation, the curly braces being used for, is you might know from most languages that function signature or method signature is defined by the number of arguments it takes and the type of each of those arguments and the order of those arguments. And that generally works well when a function takes 0 or 1 or 2. Maybe 3, maybe 4 arguments. After 4 arguments, your code very quickly gets messy, and you never remember what the order is supposed to be of those elements, and you're constantly consulting the documentation. And arguably at that point, if the developer has to spend more than a moment thinking about the order of the inputs, this is not the best design for the inputs to a little black box, like a function. So what you see in languages like Perl, and also to some extent PHP, but extra often in JavaScript, is passing in a hash, an associative array, an object of parameters so that you can pass in an arbitrarily ordered list of key value pairs. So you will very often in JavaScript, instead of calling a function like Let me pull up a little text editor here. Instead of calling a function like foo, comma, bar, baz, quux, where you have to remember the order and the types of these things, you would instead do something like foo, open curly brace, bar, let's say, so bar equals 1, baz equals 2, quux equals 3, and actually I got my example wrong here. I wanted to say foo 1, 2, 3. So now in the second case, where you're actually using this literal JavaScript object notation with curly braces, you can pass in all of those same arguments, but you also pass in reminders to the function as to which value corresponds to which argument, in which case now the order doesn't matter at all. And so increasingly what you see in the world of JavaScript using libraries from the likes of Google and jQuery and Yahoo and really any vendor who provides JavaScript APIs, some functions might take a total of 10 or 20 different variables, configuration variables, and the only reasonable way of doing that is to actually pass them in as this object form, especially if you think about there being functions where, what if I don't want to provide a value to that parameter? Then I have to pass in null or false or -1 or some sentinel value, and just very quickly does your list get littered. So this is very much an increasingly common approach in programming to pass in collections of key value pairs in the form of just objects. So JavaScript is quite Latin with these things. So how do you actually use this syntactically? You actually have two different approaches here. So we've been using the first, object.key, a whole bunch of times. Document.forms.registration, .email, We were just using literally the dot notation. However, I could have been using the associative array notation. It's identical. Sometimes it's useful to use this if you have weird characters as your key values, where you couldn't actually just put it as something dot something because you'd get a space or something like that. But I could have said document bracket quote unquote forms, bracket quote unquote registration, bracket quote unquote email. Same syntax. In that case starts to feel a little messy, but realize you do have these two capabilities, referencing keys with the dot notation or as though you're indexing into an associative array. At the end of the day, you are still indexing into an object even though it looks like in an array. So in JavaScript, really the two data structures are an array, which is literally a numerically indexed vector, and that's it, and an object, which is much more versatile, which can be an associative array. How do you declare an object literally? Well, you can do this. Var variable, give me an object called obj equals what? Open curly brace, close curly brace, and inside of it, give me a comma-separated list of key value pairs. Generally, if you have strings in there, you need to put quotes around the values. If the values are strings, you don't need to put quotes around the keys unless they have some potentially weird characters in them. This will be wonderfully useful when we look at something called JSON notation, JavaScript object notation, next week in the context of Ajax. Well, what about other event handlers? Right? We really just scratched the surface. We did onClick and we did onSubmit, but there's a whole bunch of others. On mouse up, on mouse over, right? In the late 90s, early 2000s, it was totally the rage to like hover over an image and it would change. And then you move it and then it would change back. Right? That was generally implemented with these event handlers, on mouse over and on mouse out. You can do these in different ways now. Libraries make this much easier, but it really reduces to the same basics that we played with already. On key down, on key up can be useful. These websites like Google and Bing that use autocomplete these days, how do they know when you've typed something? Well, they're listening for the on key up or the on key press event handler to know that the value of some form field has changed. Therefore, they should go grab the value, send it via HTTP to the server, get back a response, and bam, using CSS, show you some menu of possible matches. On blur is the opposite of on focus, so it doesn't really blur the screen. It just means the element is not possessing the blinking prompt at the moment. Someone else is. But we also have on focus, which you can detect. You realize you can do very annoying things with these event handlers. I think I griped 1 or 2 weeks ago about like Verizon's site or one of these websites where they force you to input a telephone number and they give you a field for 3 numbers, another field for 3 numbers, and another field for 4 numbers. The problem is if you make a typo in one of those fields and then try to move the cursor back into the other one, they idiotically assume that there's already 3 characters there. I'm going to move the cursor back to the next one. And you get caught in this vicious cycle where you can't change the number because they assume once the number's there, you're done with that form field. And so you have to reload, you have to jump through hoops. So realize that you can very quickly take what are nice building blocks and really abuse them if you don't think through the use cases. So beware being too helpful. And I'll get on a soapbox there for a moment too. There's absolutely no reason for a website to ask you to put in 3 digits and 3 digits and 4 digits. Let the user type in whatever they want, then use JavaScript or your server-side language to explode the 10 numbers into whatever format you want. So don't be one of those people. All right. CSS. So you actually have great flexibility. This is where CSS is a nasty little language, I think, syntactically, and the world has come up with a ridiculous number of hacks to make it do some things that you could have done yesteryear with sort of more old-fashioned HTML. But now that you have JavaScript, you can really use this language CSS and properties and class names in an increasingly compelling way, because you can use classes to put various elements in your DOM into buckets. You can use them to stylize them. You can use CSS itself to maintain state, as we'll see. In order to access CSS properties, unfortunately, the world didn't have a terrible amount of foresight here. A lot of CSS properties are things like background hyphen color or font hyphen family. Unfortunately, in the context of a programming language like JavaScript, that looks like background minus color, an arithmetic expression, or font minus family. Kind of problematic if we want to now have JavaScript properties whose names are identical to CSS. So the world decided on a reasonable but unfortunate convention whereby background hyphen color becomes background color in camel case. Font family becomes font family. So in general, anytime there's a CSS property that you're familiar with, there is a corresponding way in JavaScript to access that property if you convert the hyphenated notation to camel case with this uppercase letters for the subsequent words in the string. So this is good to know. This guy here at codepunk.hardware.org, fun sounding domain name, has a nice list. Oh, apparently Google thinks or Mozilla thinks he's illegit. I think this site is safe. I've been using it for years, so who knows what's underneath it. So this guy just has a really nice exhaustive list. But frankly, using the simple heuristic I showed you, you should be able to infer it without getting infected. So that should give you otherwise a decent list of all the conversions that are common. All right. So what more can we do here? So let me pull this up here. So blink. I promised to re-implement the blink tag, right? This is largely deprecated in all of the browsers, but let's think about how it's actually how it could be implemented. I want to implement open bracket, blink, close bracket, and any text that's inside of that, I want to be able to just turn on and turn off. Now, I know, as you might know from CSS, there's a couple ways to show something or not show something. There's the so-called display property, which can either be block or inline or none. There's the visibility property, which can be visible or hidden or one or more other things. And so I have a couple options using CSS to turn things on or off. And using JavaScript now, I have the ability to logically add a class or remove a class, or add a style or remove a style. So let's see if we can tie these things together here. I propose that this function blinker does exactly that. I first call this built-in function document.getElementsByName, quote unquote blink. That's going to give me back, by definition of the function, an array of elements, each of whose tag name is blink. So it's either going to be size 0 if I have no blink tags, or it's going to be non-zero. Then I have a for loop for var I equals 0. I is less than blinks.length. So if blinks is an array, blinks.length is the property, as we promised early on, I++. As an aside, especially as you read online references or books, var is not strictly necessary in JavaScript. It plays a different role in different contexts. In the interest of having very locally scoped variables, I would get into the habit of using var as often as possible. Really, the interesting cases arise in the context of like global variables. But for now, we'll simplify things and just say put var in front of your variables to have a variable called something. So what's my code next doing? If the ith blinks element, so blinks is an array, if the ith element, which is a specific blink tag, has a style property whose visibility CSS property is quote unquote visible, what do? Right, change it to quote unquote hidden, which should have the effect, if the browser is monitoring these CSS changes to the DOM, which it should be, it should have the effect of turning that tag appearance from like black text or whatever it is to no text at all. But the difference, as an aside, between visibility and display, if you change the display of an element from block to none, if it was taking up this much space and you make it none, that element takes up no space, whereas visible just kind of hides it behind a little invisibility cloak of sorts. So it doesn't move things around on the page, which is generally a good thing. Otherwise, if it's already hidden, go ahead and make it visible. So now I have the building blocks for getting all of the blink tags and inverting their visibility state. So what remains conceptually for me to implement? The timer. I need to call this blinker function every second, every half second or so. So let's actually put this into context. So I have a little code here that I whipped up beforehand. It has not too much more code. Look at down here. I kind of cheated and used old school HTML here, but that's fine because I'm implementing the blink tag after all. I've got the center tag, the blink tag, and then an H1 tag, hello world. So I just want this site to say hello world, sort of 1994 style. So how am I going to do this? Well, another method that's a method that's associated with the window. There's this slight distinction between the window, which is sort of the superstructure in which everything lives, and the document, which really refers to the content that came from the server, not necessarily from the browser itself. So window.setInterval does what the name implies. It calls the following function every some number of milliseconds. Seconds probably would be a pretty boring demo. So milliseconds. So 500 is half a second. So call this function every half second. And now it's going to use that for loop to grab all of the elements all at once. So hopefully I don't run into a weird case where I'm calling this function again and again. Kind of have to assume some decent performance here or implement this differently. I took a simple approach and just said call this function every 500 milliseconds in perpetuity. So the end result looks like this. This is blink.html. And there it is, 1990s again, resurrected. So the point for now, though, is how we have this other tool, this window.setInterval. And again, now we're commingling JavaScript and CSS. So we're getting some increasingly sophisticated functionality there. All right, so what more can we do here? So turns out that with libraries, YUI is kind of a personal favorite, though I'm kind of a fan now of XJS. jQuery is certainly all the rage. And these are, again, libraries we'll talk maybe a bit about during the course, but it's really good fodder for final projects. If you want to go bite off one of these libraries, it's a good way to, a good forced opportunity to pick up yet another skill that's tangential academically, but in the real world quite useful. So it turns out that YUI, which we've mentioned before, it has a library function called addListener that allows you to add, call a function in response to some event. So here I'm adding a listener to the window. It is going to be called anytime the window is loaded, which thankfully is only going to happen once. What function is going to get called? Well, I don't need to give it a name because this code exists only for this purpose. So we can use one of these things called an anonymous function or lambda function, which you define just by calling function followed by parentheses, no function name. Curly brace, write your code, and then do the opposite. Close curly brace, and then close parenthesis to close the actual call to add listener, semicolon. So this is an alternative way to implementing the same thing without using window.setTimeout or setInterval. The only reason I'm using this is because if your code's getting more sophisticated, your application might have multiple event handlers, best to channel them all through some library so that if you have multiple such queries, you're not overriding the previous handler that you configured on, say, that window. Well, what are some of the libraries? Frankly, JavaScript, I think, is great fun these days. There are so many fun widgets and libraries out there. It's really lowering the bar to getting interesting work done quickly. Again, case in point, not to harp on this, but only because it's something I've been pouring so much time into of late, this event site is implemented so much faster now than it was, say, 5 years ago in its first version. Because again, even something like this, a little date picker, a little widget like this, you could spend days getting that right, implementing the left arrow and the right arrow and the hovering. But just being able to call one line of code with some parameters and get this into your program is really quite compelling. The autocomplete I mentioned, I can search for something like the CS50 calendar and it instantaneously seemingly autocompletes. But what's really happening underneath the hood there is I implemented a little function that uses the regular expression object that then compares against a list of like 200, 300 calendar names, and then very quickly only returns true for the ones that actually match that pattern. And this, too, you're able to bootstrap quite quickly these days because of these libraries. So this site here happens to be using XJS, which is now made by a company newly branded as Sencha, but they have a GPL version of the code and also a commercial license for the code, which is not uncommon in this space to have these two versions based on your purposes, commercial or otherwise. But here are some of the most popular in the JavaScript world. So Dojo is a popular one for visual widgets, things that do neat things aesthetically. I would say from personal experience, popular, documentation kind of subpar. Every time I try to give it another shot, I just get frustrated at how high the barrier is, at least to someone with my lack of attention span to actually diving into it. By contrast, XJS's documentation is wonderful, almost too complete. I find myself getting overwhelmed by just how many methods they provided for each of these widgets. So for me, it felt like a steep learning curve. It was a good day or two to really wrap my mind around how their library works, but I'm so happy since. We're in a wonderful relationship right now. YUI is kind of where I was coming from, but as you might have noticed from context, YUI's shortcoming, if any, is it's very verbose. It's kind of like the document.forms.registration. Everything you do is so deliberately spelled out. They're actually improving this in YUI version 3. This is YUI version 2. 3 is not fully fleshed out yet, but they're stealing a lot of the ideas that have worked so well in jQuery and making syntax so much more succinct. And that's really what people like, is the succinctness in particular of jQuery. So jQuery on this list, I don't know statistics offhand, but anytime you Google or look up a list on these things, jQuery is always kind of at the top of the list. jQuery provides some nice library tools for abstracting away some of the functions we looked at today, like the set interval and the get element by ID. It also has some user interface widgets, like date pickers and the like, but not nearly as many as XJS, not nearly as many as YUI. So there's these trade-offs there. Prototype was all the rage years ago. It too has some neat features. If I pull up their site, one of the neat things you see at first, which previously you would expect only on a site that uses something like, oh, did they get rid of it? Oh, sorry, wrong site. Scriptaculous is the site I was thinking of that uses, I believe, Prototype. Previously, you would only see something like this on a site that supports Flash. But if I right-click on this, there's no Flash on this page. All of that animation was JavaScript. So this just testifies to the fact that using JavaScript and some timers and some nice animation in CSS, you can make pretty impressive sites without using Flash, without having to use a proprietary technology or plugin. You can make something that's arguably much lighter weight as well. You don't need any of this stupid little loading icon as it downloads tens of, or rather hundreds of kilobytes of data. You can do it fairly elegantly now in client-side code. The other one on here, MooTools, is another one that's popular, but perhaps not as rich. I would say in terms of popularity and maybe applicability in the real world, definitely jQuery is one to consider for final projects or for fun. XJS is quite popular, YUI, and then the others feels like they're kind of in the same buckets, but I'm sure someone has done some research online as to which is the most popular. So now we're really entering a world where there still are some disparities between browsers' implementations of certain things, which is nothing but a headache, but thankfully there's some really nice, smart people out there that kind of fight the battle for us and then post their findings. I think I might have mentioned this site before, but quirksmode.org, it's a wonderful resource where if you're really looking for a geek's answer to some corner case, I mean, this fellow has really done a nice job at fleshing out some of the annoying but interesting corner cases that arise with CSS, with JavaScript, and with HTML itself. JSLint, this is a JavaScript static analyzer utility, which means you can upload your JavaScript or copy paste your JavaScript into this utility, and it will essentially analyze it in a similar spirit to the W3C's validator, but it will actually do some syntax checking and it will actually push you toward writing better JavaScript code. In fact, I generally use this tool before I do something called minify my JavaScript, because it points out all of the potential ambiguities in your code, tells you you should really have more curly braces here, more parentheses here, just to make sure there's no ambiguities in your code, which is ever so important if you proceed then to get rid of all white space, which is useful for performance, for obfuscation's sake, and also just for compression. So debuggers, Firebug is probably hands down the best or one of the best, though Safari or more generally WebKit and also IE do have their own built-in ones. Personally, I've never found them as user-friendly as Firebug, but realize there are some JavaScript debuggers out there included in Firebug and this other one here. Again, I'll post these URLs online. And then compressors. So we've talked briefly about this. Google's homepage is very much compressed. There's barely any white space there, and that's for money reasons and performance reasons, presumably. There's a lot of tools out there that are free that allow you to take JavaScript code that's not in your HTML necessarily, but in an external JS file that allows you to compact it to either raise the bar to someone just stealing all of your hard work, although if it's readable by a machine, it's going to be readable by a human as well, or at least save some bytes. So that's our quick introduction to JavaScript today. Next week, we'll look at Ajax and things much more dynamic as we move toward even more dynamic websites. See you then.